Balancing Equations, Part 1. The balancing equations flowchart can be used to determine the type of chemical reaction. Usually, this is the first step in determining how to balance the equation. The balancing equations flowchart provides a guide for steps in balancing equations. The flowchart will be available during the quiz. Example 1. Use the balancing equations flowchart to determine the type of chemical reaction. CH4 plus 2O2 yields CO2 plus 2H2O. You go to the start position, and the first decision is, does this compound contain carbon and hydrogen? Sometimes it will also have oxygen, plus oxygen and two or more products, and the answer is yes. This is a combustion reaction, and the product is always the same, CO2 and water. You assume there's sufficient oxygen. If there's insufficient oxygen, carbon monoxide will be formed. We will only consider complete combustion, however, in this course. So when you have a combustion reaction, you can assume the products will be CO2 and water because there will be sufficient oxygen for complete combustion. The correct answer is combustion. This is a combustion reaction. Example 2. Use the balancing equations flowchart to determine the type of chemical reaction. We start here. The first decision, do we have a carbon, hydrogen plus oxygen? And the answer is no. Do we have an element, one capital letter, and a compound, more than one capital letter, giving me an element, one capital letter, and a compound? And the answer is yes. This is a single replacement reaction. The element by itself, zinc, has to be more active than the element in the compound, lead. If you look at the table of reactivity, zinc is above lead, zinc is more active, zinc will go with the acetate, and lead will go by itself. The correct answer is single replacement. When you have an element and a compound, and an element and a compound, it's a single replacement reaction. Example 3. Use the balancing equations flowchart to determine the type of chemical reaction. I start here, and here's my first decision. Do we have a carbon, hydrogen plus oxygen? No. Now I'm right here. Do I have an element plus a compound? No. That's a compound and that's a compound. So I'm going to here. Do I have a compound plus a compound? Yields, that's what the arrow stands for. Compound plus a compound. Yes. This is a double replacement reaction. You swap partners. The sodium goes with the chlorine, and the aluminum goes with hydroxide. So outsides goes together and insides go together, and make sure that you write the positive ion first in the compound. A double replacement reaction will occur if it forms a gas. This is your list of gases. You will have the list of gases on your test. You do not have to remember them. Or it forms water, or one of the products will be insoluble, won't dissolve. The hydroxides are not soluble, they won't dissolve. The exceptions are group 1, that's that first column, ammonium, calcium, or barium. So this won't dissolve. The chlorides do dissolve, they're soluble. So the correct answer is this is a double replacement reaction, and you can tell it's a double replacement because a compound plus a compound yields a compound plus a compound. Example 4. Use the balancing equations flowchart to determine the type of chemical reaction. We start here in the first decision. Do we have a carbon-hydrogen or sometimes oxygen compound plus oxygen? And it yields 2 or more products. The arrow means yields. I do not have a plus sign on the left side of the equation, the reactant side, so the answer is no. I go to the next decision symbol right here. Do I have an element plus a compound yields an element plus a compound? I do not have a plus sign on the left side of the equation, so the answer is no. I go to the next decision. Do I have a compound plus a compound yields a compound plus a compound? No, I do not have a plus sign on the left side of the equation. So I'm at this point in the table. Do I have one compound yields and then I have a plus sign on the right? Yes. I do not have a plus sign on the left. So yes. This is a decomposition. And you can tell it's a decomposition because there is no plus sign on the left side of the equation. Example 5. Use the balancing equations flowchart to determine the type of chemical reaction. We start here in our first decision. Do we have carbon-hydrogen compound, sometimes oxygen, plus O2, and then 2 or more products? No, there is no plus sign on the right side, the product side, so the answer is no. The next decision is right here. Do we have an element plus a compound yields an element plus a compound? No, there is no plus sign on the right side of the equation. We're at this point in the table. Do we have a compound plus a compound yields a compound plus a compound? No, there is no plus sign on the right side of the equation. We're at this point in the table. Do we have one compound yields and then 2 more products? No, there is no plus sign on the right side of the equation. So we're at this point in the table. Do we have a reactants and then 1 product? And the answer is yes. This is a composition or sometimes synthesis reaction. It is real easy to tell you have a synthesis reaction. There is no plus sign on the right side of the equation.